Section 1.2, graphs and lines. The graph of a function is a set of all the ordered pairs that are solutions to the equation. So if we took the x and the y and plugged them back into the equation together, they would make the equation true. The simplest way to graph a function is just to make a table of x-y pairs and then plot all the points. And you plot as many points as you need until you can start to see the shape come together when you connect the dots. When you're making your table, remember that you can choose arbitrary numbers from your domain. So choose what you want for x, plug it into the equation to calculate y, and then plot all of those pairs. If we can write the equation or the rule of the function as y equals mx plus b, or f of x equals mx plus b, where x and y are just to the first power. So we see no exponents, we don't have x in the denominator, we don't have square roots. We call that a linear function. It's called linear because the graph is always a straight line. So let's stop the word line, write it there. 2 points is enough to graph a line. So if you can find any two solutions to the equation, you can plot them and draw a line through them with arrows in both directions to draw the graph of that function. So here if we want to graph this function f of x equals 2x plus 5, which we can recognize as a linear function, we just need to find two solutions and plot them. We can choose anything for x. So let's say that x was equal to 1. So the question is, when x is equal to 1, what is y or f of x equal to? So here you're just plugging in 1 for the x. And if you prefer to change f of x to y, there is no problem with that. But we're replacing the x with the 1 to figure out what we get for y. So in this case, y is 2 plus 5. So it would be equal to 7. So when x is equal to 1, y is equal to 7. So now I have this ordered pair 1, 7 that I can plot on my graph. To graph this line, we need one more solution. So you simply just choose another x, anything you want for x. Maybe I want to see what happens when x is negative 1. X is negative 1, my equation becomes 2 times negative 1 plus 5. So this time I get negative 2 plus 5, which is 3. So when x is negative 1, y is equal to 3. So there's another point to put on my graph. So I'm going to plot these two. 1, 7. So I'm going to go to the right. So starting at the origin at 0, 0. I'm going to go to the right 1. So x tells me where to go left or right in the x direction along the x-axis. And the y-coordinate tells me where to go up and down on the y-axis. So I'm going to the right 1, and then I'm going up 7. And I'm going to put that point there. And then to plot the point negative 1, 3. Since my x is negative, I need to go to the left. So I'm going to the left to negative 1 and then up to 3. And I'm just going to draw a line between those 2 points. And putting arrows on the end indicates that this little line that I've drawn is not all the solutions. That if I keep going off of this grid infinitely, there are more solutions to this equation. And in between my dots, everything along that line, every single point is a solution to this equation. So we're using the graph to represent all of the solutions because we could never make a list long enough to list all of the solutions to this equation. There are a few other ways that you could draw the graph of a straight line. Another way is that we could use the slope and the y-intercept. So the good thing about this y equals mx plus b equation, this is called slope-intercept form. And they call it that because from the equation, you can see the slope and you can see the y-intercept. The y-intercept is where the graph crosses the y-axis. And in this equation, they're represented by m and b. So m is the slope, and b is just the y-coordinate from the y-intercept. So it would have the ordered pair 0, b on the y-axis. So if your equation is already in this form, so let's just for an example, say we've got y equals 1/2 x minus 4. It's in slope-intercept form, so I can tell by looking at it what is the slope, what is the y-intercept. So comparing it to y equals mx plus b, this would be m. 1/2. And the -4 is b. So I know from this equation that the slope is 1/2. And the y-intercept, x-coordinate is always 0 on the y-intercept. Anywhere on the y-axis, the x-coordinate is 0. And then that b is -4. You can use the slope and the y-intercept to draw the graph. In order to do that, you would just plot the y-intercept and then use the slope to move to the next point. Right? So if I know that the y-intercept is 0, -4, I'm going to plot that first. And then remember that the slope, tells you the rate of change, the change in y over the change in x. So this one's already a fraction, so you can use your rise over run. So the numerator of that fraction tells me the rise. So that's a vertical movement. Where am I going in the y direction? The 2 is the run, so it tells me where I'm going left and right in the x direction. They're both positive, so I am going to go up 1 for the rise and to the right 2 for the run. So I'm starting at my y-intercept and I'm going up 1 and to the right 2. One note to make here, this equation has a positive slope, and you can see that my line is increasing from left to right. If your slope is negative, then your line should be coming the other way, so decreasing from left to right. And you can kind of use that to double check when you're graphing. So next example, we've got an equation that's not in slope-intercept, but we still can find the slope and the y-intercept from this equation. We just need to rearrange it a bit to put it in slope-intercept form. Notice that in slope-intercept form, the equation is solved for y. So you wanted to say y equals, and everything else is on the other side. So we're trying to get y by itself. We're just going to move some things around until we got y by itself. So I could start on adding 4 on both sides of this equation. So that would leave me with the 3x plus 2y now equals 4. Trying to get y by itself, so I don't want any x's on the left side. So I'm going to subtract this whole thing, 3x. So now I have 2y. And since I know that my goal is y equals mx plus b, I'm going to put this x term first. So I'm going to write it as -3x. And then I still have that positive 4 on there. So that's the same as if you wrote 4 minus 3x. Just rearranged it. So last step is I need to get rid of this times 2. So I'm going to divide everything by 2. So now I have y equals -3 over 2x. And I'm going to go ahead and do 4 divided by 2 to make this a 2. So now I have this equation in slope-intercept form, and I can see my m and my b. So I can answer this question and say that the slope is a -3 over 2, and the y-intercept is the point 0, 2. So you could use those, the slope and the y-intercept, to graph this. And because this slope is negative, you should get a line that's decreasing from left to right this way. If you don't have an equation and you just have 2 points, then you need the slope formula to calculate the slope. The slope formula, you're just calculating the change in the y over the change in the x. So we talked before about rise over run. Rise is the change in the y direction, and run is a change in the x direction. And to find that, you would just subtract. Subtract your y coordinates on top, subtract your x coordinates on the bottom. So you're taking your 2 y's and subtracting and putting over the difference between your x's. So if you have 2 points and you need to calculate the slope between them, you can plug them into this formula to find the slope. Here's an example. I'm given 2 points on the line and I'm trying to calculate the slope. If you're very visual and you would rather plot these 2 points and then count the slope between them, so count rise over run, that also works. Sometimes that's a little hard, like if your points have fractions or decimals. So just plugging these into the formula, I'm going to call this x1 and y1, and I'm going to call this x2 and y2, and I'm just going to plug them right into the formula. So I'm going to take 1 minus 5 over 6 minus 2. 4 over 4, which simplifies to -1. So slope here is -1. The slope formula has a little condition that the x coordinates have to be different. If the x-coordinates were the same, you would get 0 in the denominator, and that would make your slope undefined, and that graph would actually be a vertical line. So vertical lines, all of the points have the same x-coordinate, so the equation looks like x equals some number. So an example would be x equals 3. If you were graphing that, you could make a table and you find some solutions. No matter what the y is, the x-coordinate's always going to be 3. So we could have like 3, 0, 3, 1, 3, -1, and all of the points will line up vertically. You end up with a vertical line. When you're calculating slope for a vertical line, like I mentioned, you would get 0 in the denominator, and so you would end up with something undefined. So the slope of a vertical line is undefined. Horizontal lines, they all have the same y coordinate, so the equation is just y equals a number. So an example might be y equals 4. So no matter what the x-coordinate is, y-coordinate is always 4. So all of the points would line up horizontally, where y is equal to 4. So with horizontal lines, if you look at the slope formula, you're subtracting the y's on top. If the y's are the same, when you subtract, you get 0, but in the numerator of the fraction. The top of the fraction is 0 and the bottom is some number. That equals 0. So bottom can't be 0. Top is okay. So the slope of horizontal lines is 0. All right, just a recap here of the 4 types of slope. The line increasing from left to right would have a positive slope. We're decreasing from left to right, we've got a negative slope. Vertical lines have undefined slope, and horizontal lines have 0 slope. Slope is equal to 0. There's another form of the line equation that we'll find helpful when we're writing the equation of a line, and this one's called point slope equation, because we can put in a point and the slope. So if all you know is the slope of a line and one point on the line, then you can plug those things into the point slope equation to write the equation of the line. So of course, if the point that you know is a y-intercept, then you can use the slope-intercept form. If you're used to using slope-intercept form and plugging things in and finding b, then it is absolutely fine to stick with that. But we'll use the point slope equation. In this equation, we are told that the slope is -2, and then we're just given some point that the line passes through. We want to write the equation of the line. Right, so still here, our slope. Slope is m, and the point that they've given us, we're going to use that as x1 and y1. So we're just going to plug these things into this equation and then simplify it until we've got y equals. All right, so here I've substituted in m, x1, and y1. So now I'm just going to simplify. So I'm going to distribute the -2 and then add 5. All right, so here we've got the equation of the line. If we were asked about the slope and the y-intercept, now we can see that. If we had to graph it, we could do that using the slope and the y-intercept. So if you are given the slope and a point, you can just plug them into the point slope equation. If you're not given the slope, then you would just need the slope formula to calculate that first, and then you would proceed exactly like we did this problem. So far, we have graphed lines using just 2 points that we found to satisfy the equation. We use the slope and the y-intercept. Another method is to use the y-intercept and the x-intercept. X-intercept is where the line crosses the x-axis. So where we cross the x-axis, the y-coordinate is 0. So intercepts are usually easy to find for a linear equation because you're just plugging in 0 for one of the coordinates, one of the variables. So we graphed this line earlier. This one was f of x equals 2x plus 5. And maybe I wanted this line to be very accurate. So I want to know exactly where is this line going to cross that x-axis. And I kind of have an idea based on what I drew here, but I want to find out exactly. So I know that when it crosses the x-axis, y or f of x is going to be 0. So I need to put in 0 where I have y or f of x. And then I need to solve for x. So I'm trying to get x by itself. First, I'm going to subtract. And then I'm going to divide both sides by 2. And so I get negative 5 over 2 for my x-intercept. This is the x-intercept. And the coordinates of that point are negative 5 over 2, 0. And negative 5 over 2, see, that's like 2.5, 2.5. And that seems reasonable. If I drew my line a little bit straighter, yeah, that's better than what I drew before. But that's another method of graphing. If you find the x-intercept, you find the y-intercept, you plot those two and draw the line between them. So to find an x-intercept, plug in 0 for y. To find the y-intercept, you can plug in 0 for x. All right, we're going to finish this section up by talking about parallel and perpendicular lines. So what you want to remember is that two lines are parallel if they have the exact same slope. So an example would be like y equals 2x plus 5 that we just graphed, and another line, 2x minus 34. Those are different lines. They got different y-intercepts, but they have the same slope. So they're going to run parallel to one another. So I know these two lines are parallel because they have the same slopes. Perpendicular lines do intersect, and when they intersect, they create a perfect right angle. So like our x-axis and our y-axis on the coordinate plane. And the slopes of these two lines would be opposite reciprocals. So if I had a line where my slope was 2 over 3, the slope of a line that is perpendicular to it would be opposite. So that's positive. It's going to be negative. And reciprocal just flips the fraction over. Okay, so I'm changing the sign and flipping the fraction. So negative 3 over 2 would be a perpendicular slope. And I'm just making up the rest of this equation for the example. But these two lines, comparing the slope, they are opposite reciprocals. So flip it over, change the sign. That tells me that they are perpendicular lines. And this just adds an extra step if we need to write the equation. So here's an example where we want to write the equation of a line that's perpendicular to another line. So two things that we have to know to write the equation of a line are the slope and a point on the line, any point on the line. And here we have a point. They gave us a point, but we need to figure out what should we be using as the slope. So we want to look at the line that they gave us and see what's the slope of that line. And it's in slope-intercept form. I can see that what's in the M spot is 0.5, so that is the slope. Now to write a perpendicular line, I'm going to have to make it an opposite reciprocal. And for that, I need a fraction. So I'm going to rewrite this as a fraction. So it would just be 1/2. 0.5 is 1/2 as a fraction. And then to make it perpendicular, I'm going to flip it over and change the sign. Negative 2 over 1, or I'm just going to write that as negative 2 in my equation. So I took the 1/2, I flipped it over and changed the sign. That makes them perpendicular. So now that's all I need from this equation. I don't need this anymore. I'm going to use point slope. And for M, I'm going to use that slope that I just found was perpendicular. So I'm going to plug in this point and this slope. So I'm going to get y minus 9 equals negative 2 times x minus 3. And I'm going to simplify that first by distributing the negative 2. And then by adding the 9. Trying to get y by itself. So I get y equals negative 2x plus 15. So this is my new line. Goes through the 0.39. So I use those numbers for x and y. And I'm going to compare the slopes slopes. This one and that one should be opposite reciprocals, and they are. You could also graph these two lines to make sure that they look perpendicular if you wanted to double check. If you had a problem where you wanted to write the equation of a line that was parallel, you would do what we did here. Difference would just be that you would be using the exact same slope from the line that was given to you. So for parallel, leave the slope the same. Perpendicular needs to be opposite reciprocal.